Okay, so this is section 4.3 on the first derivative test, and we're doing this in live lecture today, but I am also recording it for you guys to watch later on the YouTubes. So if anyone in the live call here has questions, I might read some stuff out from the chat, but yeah, just like we have been doing the past couple sections. So let's see here. For the first derivative test, we naturally have to know some things about our first derivative. So we'll start out with some properties, and this first one should be pretty familiar to you. What the first derivative is describing is basically the slopes of tangent lines. We saw a lot of that last chapter. So this is describing the slopes of the graph's tangent lines. Okay, for our whatever function we're looking at. Now, the next couple properties here, we may or may not have explicitly pointed out last chapter, but these are things that you can kind of gather pretty quickly from what you know about the derivative at this point. So if your derivative f prime of x is positive, that means the slope of the tangent line to the graph is positive at that point. So positive tangent line slope, okay, something like that. Those positive slopes would show us that things are, or values are generally moving up as we go from left to right. So if the derivative is positive, then our function f of x is increasing in value, okay, because of that positive tangent slope. And so kind of to contrast with that, the other way around, if our derivative is negative, so if we have a negative tangent line slope, that shows a decrease in our function. So this indicates that f of x is decreasing. Okay, so positive slope, increase, negative slope, decrease. And then if the slope is 0 or if the derivative is undefined, we actually just looked at that in section 4.1 the other day. We had a special name for points where these things happened. Any of you guys on the call here remember what those points were called? Where the derivative was 0 or undefined? Yeah, someone very quick in the chat there. Very nice, critical points. So yes, those are our critical points. Okay, awesome. So let's see here. I just wanted to kind of draw us a little graph here showing kind of these properties or these things on a makeshift function. So let's see here. Draw kind of a generic little function, x and then f of x. So we'll observe all of those things happening here based on the first derivative. Okay, so there's a nice little function, and our derivative naturally describes the slopes of this graph's tangent lines. So places where our derivative is positive, we would look for those positive tangent line slopes, and that would be all over here. Okay, those are positive tangent line slopes, and then we can see they kind of level out until we get a horizontal tangent line right at the top of the hill there, so to speak. And so that is our critical point, like someone mentioned. So if we call that critical point there right up at the top, let's give that a special, just a name here. Let's call that point A, perhaps. we could say that our function is increasing on the interval here from, well, looks like from negative infinity up until a. It increases that whole time. So a lot of the questions in this section are going to ask for intervals of increase and decrease. So we can say here that f of x is increasing on the interval, well, let's say intervals even, because there's going to be another one. But one of those is from negative infinity up to a. And we'll use interval notation for this, since it will often ask for interval notation, like on my math lab, for instance. So from negative infinity up to a, that's an increase. And then we would have another little area of increase here from our low point. Let's call this guy B here. On after that. And you can see again the positive tangent line slopes on that portion of the graph. We've got a nice critical point at B. There's that horizontal tangent line, f prime of x equals 0. But then moving out after that, the tangent line slopes are positive again. And we can see that, yeah, this part of the graph is increasing. So for our interval notation, we would indicate that second interval by using a union symbol. So that's like the and also this other interval. Okay, and so that other interval goes from B to infinity. And we are keeping those as open intervals, like we're not necessarily including A or B, because at those points, like right at the critical point, we can't really say that the function is increasing or decreasing there, honestly, because it's just a critical point. The derivative is 0, so there's not really increase or decrease happening at A or B. So that's why we stick a parentheses on there instead of like a closed bracket. Okay, so that would be matching up with our increase idea here. And so then you might be able to tell we're going to look at decrease as well, and that's going to be the part that we haven't drawn the tangent lines for yet, right in the middle here. So from our critical point at A, if we go on the other side of that, then we have tangent lines with negative slopes. They get pretty steep in the middle there. And then they start leveling off again until we get to our other critical point at B. So that's negative tangent slopes. So our first derivative is negative. And we can definitely see that the function values, like the y values for this guy, are decreasing along that interval there. So it all goes together. It's kind of nice. Graphically, it really matches up. So f of x is decreasing on the interval from A to B. And yeah, again, we don't include either of the endpoints because yeah, it's not really increasing or decreasing at those points. Okay, so that is our idea of increase and decrease. And that plays really nicely into what's going to become our first derivative test here. But I'll pause for a moment and we'll make a new video for that first derivative test.